Good day, students and parents! Welcome back to Valenzuela Facebook Live. Together, let us start year 2022 with our eyes open to see and experience new things, our hearts open to welcome new people in our lives, and our minds open to welcome new learnings. Today, we are on our quarter 2, week 5, and we will be discussing lessons 7 and 8. Lesson 7 is about the laws of exponents, and lesson 8 is about multiplying and dividing polynomials. Our learning competencies for lesson 7 derives laws of exponents. Moreover, for lesson 8, multiplies and divides polynomials. To start, let me ask you, have you ever heard of the word exponent? I know you do. An exponent is the number that tells us how many times a number is used as a factor. For example, in 3 times 3, 3 is used as a factor twice. Therefore, we can write it as 3 raised to 2, where 3 is what we call the base and 2 is what we call the exponent or power. So, 3 raised to 2 means that you are going to multiply 2 3s. So, 3 times 3 equals 9. So, what are these so-called laws of exponents? These laws of exponents are the product law of exponents, quotient law of exponents, negative exponent rule, zero exponent rule, and the power of a power law of exponent. Let us discuss first the product law of exponents. In 3 raised to the second power multiplied by 3 raised to the fifth power, we are dealing with exponents. The first thing that you need to look into is if they have the same bases. In this case, the bases are 3 and 3. So we have same bases. Therefore, we just copy the base 3, and with regards to their exponents, 2 and 5, according to product law of exponents, we need to get their sum. So that will be 2 plus 5. The product law of exponents states that to multiply powers of same base, simply copy their common base and add their respective exponents. So, that gives us 3 raised to the 7th power. For example, x raised to the 3rd power multiplied by x raised to the 8th power. We have same bases which are x and x. So, we just copy x. Then, since we are multiplying same bases according to the product law of exponents, we need to add their respective exponents 3 and 8. So, we have 3 plus 8, which gives us x raised to the 11th power. This time, let us have the quotient law of exponents. In 3 raised to the 6th power over 3 raised to the 4th power, over also means division. As you can see, we have a same base which is 3. So, we just copy 3, and with regards to their exponents 6 and 4, according to quotient law of exponents, we need to subtract the exponent in the numerator minus the exponent in the denominator. Then, that will be 6 minus 4. Quotient law of exponents states that when we are dividing powers of the same base, simply copy the common base and subtract their respective exponents. So, that gives us 3 raised to the 2nd power. Let us have an example. X raised to the 8th power over x raised to the 3rd power. Since we are dividing powers of same bases, we can apply the quotient law of exponents. We just copy the same base, which is x, Then subtract their respective exponents, 8 and 3. So we have x raised to 8 minus 3. That gives us x raised to the 5th power. Next, we have the negative exponent rule. If we have 3 raised to negative 2, that is equal to 1 over 3 raised to positive 2. The negative exponent rule states that if the base is a non-zero real number and a negative exponent is encountered, get the reciprocal of the number to make its exponent positive. For an example, 3x raised to negative 2 is the same as 3 times x raised to negative 2. Since x has a negative exponent, we apply the negative exponent rule. So, we are going to get its reciprocal, which is 1 over x raised to 2. Then, we have 3 times 1 over x raised to 2. Multiplying, we have 3 times the numerator 1, which gives us 3 over x raised to 2. Next is what we call the zero exponent rule. If we have 3 raised to 0, this is equal to 1. Because the zero exponent rule states that if any non-zero real number is raised to 0, the value is 1. For example, 4x raised to 0 is equal to 4 times x raised to 0. X raised to 0, applying the zero exponent rule, will be equal to 1. So that will be 4 times 1, which is simply 4. Now, let us discuss power of a power law of exponent. Under this, we have power of a product law. If we have the quantity of 3 raised to 2 raised to 5, applying the power of a product law, we are going to multiply the exponents 2 and 5. So that would be 3 raised to 2 times 5. Power of a product law states that a term raised to a power is equal to the product of its factors raised to the same power. So, that would be 3 raised to the 10th power. Another one is the power of a fraction law. If we have the quantity of 2 raised to the 2nd power over 5 raised to the 3rd power raised to 4, by power of a fraction law, we multiply the exponent outside the parentheses to each exponent in the numerator and the denominator. So that would be 2 raised to 2 times 4 over 5 raised to 3 times 4. Multiplying the exponents give us 2 raised to the 8th power over 5 raised to the 12th power. So, those are the laws of exponents. The product law of exponents, which states that when we multiply same bases, we add the exponents. The quotient law of exponents, which states that when we divide same bases, we subtract the exponents. The negative exponent rule, which states that to make a negative exponent positive, just get its reciprocal. The zero exponent rule, which states that any term raised to 0 is equal to 1. Then, the power of a product law, which states that when you have an exponent raised to another exponent, you just multiply the exponents. And finally, the power of fraction law, which states that when a fraction is raised to a power, you multiply the exponent outside the parentheses to each of the exponents in the numerator and the denominator. Now, see for yourself how much you understand about this lesson by answering the following practice questions. All you have to do is to simplify the following expressions using the laws of exponents. Are you ready? Great! For the first one, simplify the quantity of 3xy raised to 2. For color daffodil, it's 9x raised to the second power, y raised to the second power. While for color cyan, it's 6x raised to the second power, y raised to the second power. Is it daffodil or cyan? Correct! The answer is daffodil. 9x raised to the second power, y raised to the second power. Next, simplify x raised to negative 2, y. Is it 1 over y, x raised to the second power, or y over x raised to the second power? Is it daffodil or cyan? Very good. The answer is cyan. Y over x raised to the second power. Doing great? Let us continue. This time, simplify 2xy multiplied by 7xy. For daffodil, it's 14x raised to the second power, y raised to the second power. While for cyan, it's 14x y raised to the second power. Is it daffodil or cyan? You are right. The correct answer is daffodil. 14x raised to the second power, y raised to the second power. Well done, class. I know you'll do well answering your modules. This time, we are going to proceed with Lesson 8, which is about multiplying and dividing polynomials. Let us have first multiplying polynomials. So to multiply polynomials, we just need to follow a few steps. First, multiply each term in one polynomial by each term in the other polynomial. Then, combine like terms and simplify if needed. Let us try multiplying a monomial by a monomial. If you can still remember, a monomial is a polynomial with just one term. So let us have the first term 2x raised to the second power, y raised to the fourth power, multiplied by the second term, which is 3x raised to the sixth power, y raised to the third power. First is to multiply their numerical coefficients, which are 2 and 3. Then, multiply the ones with the same basis, like x raised to the second power and x raised to the sixth power, and y raised to the fourth power and y raised to the third power. Now, we apply the product law of exponents, wherein if we are multiplying same bases, we just copy the common base and add their respective exponents. So that would be 2 times 3 multiplied by x raised to 2 plus 6, y raised to 4 plus 3. Simplifying further, we have 2 times 3 is 6. Then, x raised to 2 plus 6 would be x raised to the 8th power. And y raised to 4 plus 3 would be y raised to the 7th power. This time, how about multiplying a polynomial with a monomial? We have 3 times the quantity of x plus 4. In multiplying, we are going to apply distributive property, which means we are multiplying the number outside the parentheses to each term inside the parentheses. That makes 3 times x, which is 3x, and 3 times positive 4 is 12. Let us have another example. We have 5x times the quantity of 2x raised to the second power plus 3x minus 7. Applying distributive property, we will multiply 5x to each term inside the parentheses and apply the product law of exponents by adding the exponents to those with same bases. Then, we have 5x times 2x raised to the second power is 10x raised to the third power. 5x times positive 3x will be 15x raised to the second power. And 5x times negative 7 will be negative 35x. Since there are no more like terms here, this will be our final answer. Next, we have multiplying a binomial by a binomial. Remember that a binomial is a polynomial with two terms. Let us try to multiply the binomial 2x plus 3 by another binomial, which is x minus 5. In this case, we are going to use what we call the FOIL method. In FOIL method, F stands for the first terms, which means multiply the first terms of each binomial. Then, O stands for outer, which means multiply the terms on the outer side. I for inner, meaning multiply the terms on the inner part. And L for last, which means multiply the last terms of each binomial. It's simply an acronym to remind us how to multiply a binomial by a binomial without missing out anything. So, applying FOIL method, let us compute for the product. We have 2x times x is 2x raised to the second power. 2x times negative 5 is negative 10x. Then, 3 times x is positive 3x. Finally, 3 times negative 5 is negative 15. Since negative 10x and positive 3x are like terms, we can still combine them. Negative 10x plus 3x is negative 7x. Therefore, the product of the two binomials above is 2x raised to the second power minus 7x minus 15. Let us try one more example. Multiply 4x minus 2 by 3x minus 5. Applying FOIL method, we will have 4x times 3x is 12x raised to the second power. Then, 4x times negative 5 is negative 20x. Next, negative 2 times 3x is negative 6x. Finally, negative 2 times negative 5 is equal to positive 10. Since negative 20x and negative 6x are like terms, we can still combine them. Negative 20x minus 6x gives us negative 26x. Therefore, our final answer is 12x raised to the second power minus 26x plus 10. Furthermore, if we multiply a polynomial by a polynomial, like x raised to the second power plus 2x minus 3 times 3x raised to the second power plus 5x plus 2, first, multiply the first term x raised to the second power to each term on the other polynomial, which will be x raised to the second power times 3x raised to the second power is 3x raised to the fourth power. Then, x raised to the second power times positive 5x is 5x raised to the third power. Next, x raised to the second power times positive 2 is 2x raised to the second power. This time, multiply the second term to each term of the other polynomial. So that will be 2x times 3x raised to the second power is 6x raised to the third power. We are going to write it below its like term so that it would be easy for us to combine all like terms later on. Then, 2x times positive 5x is positive 10x raised to the second power. And 2x times positive 2 is 4x. Finally, we multiply the last term of the first polynomial to each term on the other polynomial. So that will be negative 3 times positive 3x raised to the second power is negative 9x raised to the second power. Again, we write it aligned to its like terms. Then, next, we have negative 3 times positive 5x will be negative 15x. Finally, we have negative 3 times positive 2 is negative 6. Now, we need to combine like terms. So, we have 3x raised to the fourth power, then 5x raised to the third power plus 6x raised to the third power is positive 11x raised to the third power. Then, positive 2x raised to the second power plus 10x raised to the second power minus 9x raised to the second power gives us positive 3x raised to the second power. Then, positive 4x minus 15x is negative 11x. Then, minus 6. Since all the like terms were already combined, this will be our final answer. Finally, we have dividing polynomials. In dividing polynomials, you first divide or get the lowest term of the numerical coefficients, then apply quotient law of exponents on their literal part. For example, we need to divide the quantity of 8x raised to the second power, y raised to negative 2, all over 2x raised to the sixth power, y raised to the fourth power, raised to 3. First, we are going to apply power of a fraction rule, followed by quotient law of exponents and the negative exponent rule. First, apply power of fraction rule, which tells us that each exponent in the numerator and the denominator will be multiplied by 3. So that would be 8 raised to 3, x raised to 2 times 3, y raised to negative 2 times 3 over 2 raised to 3, x raised to 6 times 3, y raised to 4 times 3. Simplifying further, we will get 8 raised to the third power is 512, x raised to the sixth power, y raised to negative 6, over 2 raised to 3 is 8, x raised to the 18th power, y raised to the 12th power. 512 divided by 8 is 64. Then, for the exponents, we will apply the quotient law of exponents by subtracting the exponents of those with the same bases. That would be x raised to 6 minus 18 and y raised to negative 6 minus 12. Then, we will have 64x raised to negative 12, y raised to negative 18. Since we have negative exponents, we will apply the negative exponent rule. We need to make them positive by getting their reciprocals. Then, we will have 64 times the reciprocal of x raised to negative 12, which is 1 over x raised to the 12th power, times the reciprocal of y raised to negative 18 is 1 over y raised to positive 18. Then, simplifying, we have 64 over x raised to the 12th power, y raised to the 18th power. We also have dividing a polynomial by a polynomial by using long division. For example, we have 4x raised to the second power plus 10x plus 4 divided by x plus 2. The first thing to do is to focus on their first terms and divide it. 4x raised to the second power divided by x is 4x. We write it right above its like term. Then, 4x times x is 4x raised to the second power. Then, 4x times positive 2 is positive 8x. Subtracting the terms, we have 4x raised to the second power minus 4x raised to the second power is 0. 10x minus 8x is positive 2x. Then, bring down plus 4. Now, repeat the process. Divide the first term 2x by the first term x. That would be positive 2. Multiply positive 2 by x is 2x. And positive 2 times positive 2 is positive 4. Subtracting, we will have 0. Therefore, our quotient is 4x plus 2 with a remainder of 0. Let us have one more example. X raised to the second power minus 4x plus 11 divided by x plus 2. First term divided by first term, we have x raised to the second power divided by x is x. Multiply x times x is x raised to the second power. Then, x times positive 2 is positive 2x. Next, subtracting, we will have x raised to the second power minus x raised to the second power is 0. Negative 4x minus 2x is negative 6x. Bring down plus 11. Repeat the process. Negative 6x divided by x is negative 6. Multiplying, we have negative 6 times x is negative 6x. And negative 6 times positive 2 is negative 12. Subtracting, we have negative 6x minus negative 6x is 0. 11 minus negative 12 is positive 23. 23 is called the remainder. Therefore, our quotient is x minus 6 plus the remainder 23 over the divisor x plus 2. Again, before we conclude this lesson, let us have some practice questions. What you need to do is to find the product or quotient of the following polynomials. For the first one, multiply 2x and 6x plus 5. For daffodil, it's 12x raised to the second power plus 10x. While for cyan, it's 12x plus 10x. Is it daffodil or cyan? Correct. The answer is daffodil. 12x raised to the second power plus 10x. Next, divide 10x raised to the 8th power, y raised to the 6th power, z raised to the 7th power, over 2x raised to the 5th power, y raised to the 2nd power, z raised to the 7th power. For daffodil, it's 5x raised to the 3rd power, y raised to the 4th power, z. While for cyan, it's 5x raised to the 3rd power, y raised to the 4th power. Is it daffodil or cyan? Great! The correct answer is cyan. 5x raised to the 3rd power, y raised to the 4th power. Finally, simplify x raised to the 2nd power plus 4x plus 4 over x plus 2. For daffodil, it's x plus 2. While for cyan, it's x minus 2. Is it daffodil or cyan? The correct answer is daffodil, x plus 2. Well done, class! That concludes our lesson this morning. I hope that you learned from today's discussion and that you will be able to apply the skills and the knowledge in answering your modules. Let me leave you this thought to ponder as a closing for our discussion this morning. Brian Herbert once said that the capacity to learn is a gift. The ability to learn is a skill. And the willingness to learn is a choice. As we face this new year, may we all find at least the willingness to learn within our hearts. Again, this is Ma'am Christine Gregorio Noriega, wishing everyone a happy 2022 ahead of us. Happy morning!